Okay, we're going to talk about chemical equations and balancing chemical equations, and then we'll do some actual stoichiometry with this information. Chemical equations. So we're going to use chemical symbols to show what happens during a reaction. And you have to balance the equation in order to satisfy the law of conservation of mass, because we can't lose any mass. And you can only balance the equation by adding coefficients. You can never change a subscript by balancing the equation. Now, if you have to write a formula, you're going to be adding subscripts, but to balance the equation, after you have the correct formulas, to balance the equation, you can only add coefficients. And the coefficients are the big numbers that are in front, like this 2 and this 2 are the coefficients. So chemical reaction is the process in which one or more substances are changed into one or more different substances. We always have a reactants. We'll have reactants and products. Reactants are what we start with, and they are listed on the left of the arrow, and the products are what are produced, and it's on the right side of the arrow. So this is a chemical equation here where we have, what would the name of this formula be? What's the name of that compound? Ammonium dichromate. So we have ammonium dichromate yielding nitrogen gas. That would be chromium 3 oxide plus water. Is it balanced? Yeah. How many nitrogens do we have? 8. No? 8. We just have 2. 2 nitrogens, so we have 2 nitrogens on this side. Let me write this. So we have nitrogens, there are 2. And on this side, there are 2. How about hydrogens? 8. And is there 8 on this side? Yeah. How about chromium? 2. And on this side? 2. And then oxygens? And on this side? 3 plus these 4. So we have 7. So it is balanced. So we are going to go by each element and balance each element separately. You guys remember doing this in physical science? Yes. Some indications when we're doing a lab that a chemical reaction has occurred. You'll see heat or light. Like when we burn the magnesium, you saw that bright light. Now sometimes you produce heat and not light, but usually if you produce the light, you also produce heat. Production of a gas. A lot of times we will produce gas when you mix 2 liquids. So what would you see if you produce a gas when you mix 2 liquids? Sometimes smoke, but rarely. What does gas do in a liquid? What does it make? Bubbles. You'll see bubbles forming. Yes. And then formation of a precipitate. And a precipitate, the actual definition is one phase of matter produced in a different phase. So if we think of like rain, precipitation, that is a liquid that has been formed in the gas of the air, or snow is solid that's been formed in the gas. In our case, we will usually be mixing liquids, 2 liquids, and forming a precipitate, and the precipitate that we form is a solid. So usually we will form solid precipitates. Whenever you're reading a equation or a reaction in word form and it says the precipitate was formed, they're usually talking about a solid, unless it says a gaseous precipitate, then it would be a gas. But if it just says precipitate, they're talking about a solid that's formed. Now, if you mix 2 liquids together, that whole container, a solution, will not turn into one rock solid piece. It's going to be little solid particles that would eventually settle to the bottom, but there's still going to be liquid in it. And these are some of the symbols. S stands for solid, L for liquid, G for gas, and then AQ is aqueous, which just means it's been dissolved in water. The right arrow means yields, and a down arrow means precipitate or solid is formed. Why do you think they use a down arrow? What? It's heavier, so it would sink. Right. It falls to the bottom. And then why do you think they use an up arrow for gas? It rises to the top. Yes. What one do you have a question on? Well, which one is it? All of them?
Symbols?
I know. Which one?
The up arrow.
What do you think it is?
Oh, right. It was gas.
Yep, there you go. So when you balance an equation, you need to identify all the reactants and products and write their correct formulas. It's very important that you write the correct formulas. If you don't have the correct formula, you're probably never going to get it balanced. Or you're going to balance it incorrectly, or you're just going to pull your hair out because you can't get it balanced. So if you can't get it balanced, always go and recheck your formulas. Make sure that the reactants are on the left and the products are on the right. And then we're going to make the number of atoms of each element the same on both sides by changing the coefficient, not the subscript. Don't just change the subscript. And then it's always a good habit to just go through and recheck to make sure it is balanced. So let's do some examples. We're going to write balanced equations for each of these, and it does want symbols for physical states when indicated. So the first one, hydrogen peroxide in aqueous solution decomposes to produce oxygen and water. So what is our reactants? Hydrogen peroxide, what's its formula? And what it does tell us what state it's in. What state is it? So we put an AQ. Is there any other reactants? Oxygen and water are products, right? They're produced. So we're going to put an arrow. Oxygen, what's the formula for oxygen gas? O2, right. Plus H2O. So you do need to remember the diatomic atoms. Do you remember which 7 they were? If you look on the periodic table, if there's 2 ways you could remember it. There's 7 diatomic atoms, so if you start at element number 7 and then draw a 7, so nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then you have to add hydrogen. So there's 7. Or it's start at iodine, it's I brought clay for our new house. Hydrogen is one of them. Or if you want to make up your own saying, go right ahead. But those are the ones you... So if it were to say nitrogen and water was produced, it'd be N2 and H2O. So let's check. How many hydrogens do we have on this side?
2.
And oxygens? And how many oxygens on this side?
3.
And hydrogens?
2.
Are we balanced?
Nope.
No. It's really hard to balance odd numbers, so I would try to make this side oxygen even. How would you do that? Which one? Water. Put the 2 here. So that changes this to 4. Also changes hydrogen to 4. Put a 2 on this side, and that changes this to 4 and this to 4. Very good. So just go through and recheck 4 and 4, 2 and 4 and 4. Yep.
Why do you why does it matter?
Because it tells us to include those symbols.
You don't have to do it on the right side.
It doesn't really tell us what they are. We should know that oxygen is a gas, but it doesn't tell us that it is, but yeah. So the AQ or L or S or G, they don't do anything. You don't have to balance those out. They're just showing you what state that element's in. Next, solid copper metal. Reacts with aqueous silver nitrate to produce solid silver metal and aqueous copper 2 nitrate. I'm going to get a new page. So what was it? Solid copper metal? Cu. And it's a solid. Plus if you need your ion sheet, you can use your ion sheet. It's a +1 and -1 ion though, and it's aqueous. Is that our two reactants? So our net products, solid silver metal plus, so it's Cu what? NO3, all right, don't forget parentheses 2. So those are the correct formulas, and this is aqueous, isn't it? Are we balanced? Let's see, copper has how many?
1.
And silver?
1.
Okay, now when you have a polyatomic ion like nitrate, as long as nitrate is the same on the product side and the reactant side, you can balance nitrate as a whole. So here we have a nitrate on both sides, so I'm going to balance NO3 as a whole. It'll be a little easier. And there's how many nitrate ions on the left? 1. So how many coppers on the right?
1.
Silver?
1.
And nitrate.
2.
So we are not balanced. How would we balance this?
Put it 2.
Put it to where? Okay. So that changes this to 2, but that changes silver also to 2. So we got to put a 2 here. And now we are balanced. Very good. Solid zinc metal reacts with copper 1 sulfate to produce copper metal and aqueous zinc sulfate. So solid zinc metal plus, what was it? Copper 1 sulfate, right? Sulfate is SO4, 2 minus, so that means I need a 2 here. Produces solid copper. Zinc has what charge? And 2 plus. And sulfate we said was 2 minus, so we don't need any subscripts. So now let's check. Zinc has how many? 1. And copper? And sulfate is the same on both sides, so we're going to balance sulfate. The whole, there's 1. How about zinc on this side? Copper? And sulfate? Yep, multiply that by 2, and then that doesn't change anything else. So that was 3 times 1. So these 3 have been pretty easy. We'll get to some tougher ones. Okay, I want, see, Jacob, oh, do we have a different? Okay, so Jacob's row, I want you guys to do this one. Jade's row, you're going to do the nitrogen dioxide one. Ben's row is going to do the solid potassium chlorate. And Sam's row, you're going to do this one right here. Yep. So Sam's row, make sure, does everyone have that one written down at least? That's an easier one to write down quick.
Or is it not the same?
Is it not the same?
It's the same.
C2H6 plus O2 yields CO2 plus H2O. Okay. I think Jade's row has the hardest one.
What's the difference if we put the two before or after?
That subscript only carries to the oxygen.
What if I put a big 2 at the end?
You can't put a coefficient in the middle of a compound. Coefficients only go at the beginning of the whole compound. Hey, are any of the rows ready? And I'll let you guys write your answers up. Not yet. You guys are ready? No. Remember, if you get one side to be an odd number and the other side's an even, try to get that odd number over up to an even number. How many oxygens do you get? You done? Okay.
Oh, is anybody else in the row done?
You can check with your row.
Wait, we're only supposed to do it first. Did you get it done? Oh, I did it right.
Pretend like that is the screen. So where do you need to write? Up there. So get it closer to the... You can write. Start writing up there. Uh-huh.
Oh, okay. Okay.
Right there. Brianna probably wasn't the best choice. She's a perfectionist. About I can see Brianna going through and making sure everything looked right. Yeah, So once you get your coefficients, and if your coefficients can all be reduced by a certain number, like you can divide everything by 2, do that. Make them all in the smallest number. 4. Is it H or hydrogen gas at the end? Hydrogen gas, it's diatomic, right? So it needs to be H2, which means you probably don't need the 2 in front of it. So it's one of those diatomic ones. It's one of those 7. So hydrogen by itself would be H2, H subscript 2. Just like we had for oxygen on that one. And now since you already have 2 there, you don't need a coefficient.
Nothing, the OH is by itself.
OH, hydroxide is by itself. OH isn't. Hydroxide isn't. Hydrogen and oxygen's separately, by themselves they are. Okay, and group 2, you guys have yours? No, not quite. Group 3? Who's going to write for group 3? Alyssa, you going to write? You're number 3. Oh, nitric acid? When you have to look for nitrate is NO3 and then had hydrogen. So it's HNO3.
Yeah. They were saying like NO3H. It's like,
HNO3.
You just like see it on paper.
okay, well, I just screwed up.
I like that. I like looking up there. Plus O2. Oh, erase. This is the eraser.
No, because then you have 16 or 14.
Paperclip?
Don't even care.
For what?
Well, here it is. Just take the eraser and do one hit. That's
How about this instead?
Did anyone get it in our group? Sammy?
What? Nitrogen dioxide? That's ammonia. So nitric acid, you have to look for nitrate, is NO3, and add a hydrogen, so it's HNO3. And then nitrogen monoxide would be NO, right? NO. So 1 nitrogen, 1 oxygen. There's no oxygen on the left.
That's the oxygen on the left side.
Because it would say nitrogen.
No, no oxygen. I was talking to Alyssa.
Use HNO3 plus NO.
Yep.
Yeah.
all this is just
There's 6 oxygens on each. 2 and 2. Yep, that looks good. And Sam's row, who's going to write?
Can you tell me if I got it?
I got it.
I think I got it.
We have 4 and 4. 6, that's 12 and 12. 8 plus 6 is 12 and 20.
Oh, I have to multiply.
Hey, is this right?
What do you
2746.
Oh, I was looking up here. 4,
You
4.
multiply them?
That's 12. For hydrogen, 12. And you have 14, and here you have 4. That's 8. Plus 6 is 14. Yeah.
Boom. Got it, Ben.
So this is 7.
Mm-hmm.
You want me
Who's writing?
It's 2746.
Okay, I don't know how to do it. You want to write it?
Alright.
Remember 4.
Oh. Alright.
So you okay? So like you have to multiply them. So
Mhm.
like that I multiply.
Mhm.
2 times 4.
Mm-hmm.
Okay.
This is really tough.
You don't even look at the keyboard. I got it too. Pause, right? You're good. I'll be our tribute.
You're the tribute?
You have to hold the button.
Nope. Don't hold the button, otherwise it'll make a straight line. Probably Monday. The worksheet's probably going to be due Monday because we haven't finished all the notes to finish the worksheet. So
What problems do we have to do for the chapter?
the chapter review, I could bring that up here. Or it's on the end of your notes. You have the notes there. Yep.
All of those though, you're not changing anything?
Nope. Yeah.
I'm not close. Like I think I should just try.
So you had 1 and 1, no 2. That's why you put a 2 there. Okay. Put a 2 there. That makes, by putting a 2 there, that makes that a 3. So you better change that to a 3.
Wait, what makes it a 3?
So now there's 3 nitrogens.
Where?
Because you put a 2 here,
Okay.
there's 2 nitrogens with 2 nitrogens, so that's 3. You should probably change that to 3. So now let's check oxygen. 6, that's 9. 6, 7. Let's check your hydrogens. There's 6. Oh, you only have 2 here. Why do you have that 3? Take that 3 out. Now let's just check. 2, 2. That's 6, 7, 6, 7. There's 2, 3, and 3. So we started with nitrogen, then you had a 2 here. But then we had to put a 2 here because there were 2 hydrogens, right? Which then changed our nitrogens to 3 on this side, so we changed that to 3, and then our oxygens just were bounced.
Why did you have it at instead of?
Okay. Now, okay. Let's go over that last one because there's a little trick you can do. I'll tell you what that trick is. Once Trey is... So everyone has those down? No, not quite? Whoops. Sorry, Ben. I'm going to erase the coefficients and we're going to go over this one. So if you balance the carbons first, that means you have 2 carbons here. And then when we balance the hydrogens, we have 6, so that means we need a 3 here. But that makes our oxygens odd. So we have 4 oxygens here plus 3, so that's 7. And you can't do anything with 7 divisible by 2. So your trick is to multiply everything you've done by 2. Let's double everything. So we're going to put a 2 here We're going to change this to a 4 and change this to a 6. Change this to a 4, change this to the 6. That should keep our carbons balanced. Our hydrogen should still be balanced, but it changes our oxygens on the right to an even number. Now we have 4 times 2 is 8 plus 6 is 14. So now we can put a 7 there. Okay, so that's a little trick. If you get to a spot where one element isn't balanced, one side's even, one side's odd, double everything you do, and then you should. And then if you see all your coefficients is balanced and you notice that everything is divisible by 2 or something, then do that. That's fine. So your worksheet's due Monday.